Alright, if you're just looking for the answer to this question, here it is. Basically, we cannot support this conjecture because we fail to reject the null hypothesis. If you're curious on how to solve the problem, I'll be going over it for the next couple of minutes. So here's the question. A random sample of size 25, mean 47, and standard deviation 7 is drawn from a normal population. Can we use this sample to confirm that the mean of the population is 42? So when reading this question, the big thing that we should note is that we're trying to find the mean of a population. And this basically means that we should be doing a t-test. In other words, we should be finding the t-statistic and see if our results are statistically significant. Our null hypothesis is simply that the mean is 42. In other words, kind of what we're trying to confirm. But the alternative hypothesis is that the mean of the population is actually greater than 42. And the reason for greater than is just because our sample that we got has a sample mean greater than our assumed population mean. So how do we calculate this test statistic? Well, the formula is pretty simple. It's the mean of the sample that we got minus the mean of our assumed population divided by the standard error of the sample, which is simply the standard deviation over the square roots of the number of samples that we took. So let's just simply plug in our numbers to this formula. All we have to do is 47 minus 42 over 7 divided by square root of 25. And this yields us a number that is approximately 3.57. That's the value of our test statistic. And so what do we do with this number? Well, basically, we just have to take a look at our t-statistic table and see if our results are statistically significant. Remember, we had a sample size of 25, which means that our degrees of freedom is simply n minus 1, or 24. And for this test, let's just take a look at the very, very smallest alpha value, because the smaller the alpha value, the more sure that we will be of our result. And so let's just get our t value here, 24, 0.05, and we get 2.797. And we want to see if our t statistic is greater than this value. Because if our t value is greater than this value, that means that the probability of the sample being drawn, if we assume that the population mean is 42, is even less than 0.005, right? Basically, if our t value is greater than this t value, our probability of getting this lies somewhere in this very, very small region. And we can indeed see that our 3.57 value is greater than 2.797, thus meaning that we reject the null hypothesis, and it supports the conjecture, actually, that perhaps the mean of the population is not 42 after all. And so that answers our question.